In the previous lesson, we learned that if we want to create a new type that can represent a person, it's very easy using the word struct, and then we choose a name. Here we choose name person, and this is the body of the type. And of course, this type does not represent a person yet, but we will fix it very easy. Now this type have 5 fields, which now are representing a person. Int ID, string first name, string last name, string father's name, and string mother's name. Let's see how we can use this type person. The way to use it is to declare a variable person, p1, like we did with int x or string str. Person, p1. Now we have a variable called p1 of type person. But of course this is not enough. We have to secure a place in memory for this p1 variable. And the way to do that is using the new person. New person means that we are telling the program to secure a place in memory for this p1 object, this p1 variable. And these two opening and closing round brackets, we did not explain it. In the future we will. But this is of course not enough. We only secured a place in memory for this object, for this variable, but we need also to assign values for the fields inside. So p1.id, we set a value of 1 through 7. And p1.firstname, Benjamin, and p1.lastname, Smith. Now we have a person, p1. p1 now is representing a person. We cannot set a value to the father's name and mother's name of the object of the variable p1, because the declaration of the type person was outside of our class. So our class, it starts here and ends here. And the declaration of the person type, it was outside of our class. And the protection level prevents us from interacting with fields that they are private. Here it does not say whether it's private or public, so it's private too. We can interact only with fields that they are public, because this type is declared outside of our class. So that's why we have assigned a value only for these 3 fields, and these 2 we did not. Now let's see. Here we declare another variable called p2, and we set it a value of p1. Now p1 and p2 are equal. p1 ID is 1 through 7, and p2 is also 1 through 7. P1 first name is Benjamin and last name is Smith, and P2 is also Benjamin Smith. But let's see now. Now we are changing the values of the fields inside P2. ID equals now 1, 1, 1, first name John and last name Doe. Now the question is this change to P2, ID, first name and last name, is it affect P1 too? P1 also. Is it affecting it or not? Well, the answer is that it's not affecting P1, because if we will look at the declaration of the type person, we see that we use the word struct. And when we use the word struct in order to declare a new type, then the behavior of this variable of this type are the same as int, long, byte, all of the primitive types, which mean that, for example, the object that we create using the new person is stored in stack memory and not in the heap memory, like in all other primitive types. We said that string is a little bit different, but int, long, byte, when we declare a variable, it's stored in the stack memory. So also when we create a person variable, it's also stored in the stack memory. And also, as all other primitive types, when we took the P1 and set it to P2, it means that we took just a copy of P1 and set to P2. Now, after this line, we have two variables, P1 and P2, which the values are the same, but they are not the same object. Each one of them have its own object in the memories, in the stack memory. It's equals that the values are 1, 2, 3, 2 through 7, and Benjamin and Smith after this line, of course, yeah, after this line. But they not share the same object. They have, each one of them have its own object. And that's why when we change the values inside P2, it does not affect P1, because they are two different objects. If we will print it here, we will see that ID of P1 is still 1 through 7, but the ID of P2 is 1, 1, 1, and the first name and last name of P1 is Benjamin Smith, and the first name and last name of P2 is John Doe. And also here, when we take the P1 object, P1 variable, and we send it to a method, to this method, in order to change its value, it also does not affect the P1 itself. When we send the P1 variable to a method, when we send a variable of a type that created using the struct word, then when we send it to a method, we do not send the variable itself, only a copy of this variable. Only a copy of this variable sent to this method, and it's copied to this variable, a local variable, person P. Now here inside the body of the method, we are changing the ID, the first name and the last name of the local variable P of type person. But the P1 person does not affect, because it's not that P1 itself has been sent to the method, only a copy of it sent to this method. That's the behavior of all type that struct is being used to create them.